All right, so this is Chapter 6, Section 4, Properties of Rhombus, Rectangles, and Squares. All right, our learning objective is to define and classify special types of parallelograms and to use properties of diagonals of rhombuses and rectangles. So we're going to have some special parallelograms here. A rhombus is a parallelogram with 4 congruent sides. I think of it as the caveman ancestor to the square. Kind of like a square, but has a jutting eyebrow and can barely use its stone wheel. Hunter-gatherer stage set. A rectangle is a more refined, it's like medieval friend of the square. It's a parallelogram with 4 right angles. So the only thing that we can say about a rectangle is it has 4 right angles in its corners. A square combines both of those properties, and there are 4 congruent sides and 4 right angles. So now you see how the square is walking upright versus its caveman rhombus friend back here. All right, so given the choice between rectangles, rhombus, and squares, we're going to make a little Venn diagram that shows the relationship between those 3 items. The square has both the rhombus properties and the rectangle property. And in fact, square falls under the category of rectangle, square falls under the category of rhombus. And just for bonus points, all of these items are also called what? A rhombus, a square, and a rectangle is also called a and all the parallelograms are called, Thomas, quadrilaterals. Okay, so that's the big picture. Here's the small picture, this little Venn diagram. So let's look at this nice little it's asking us if this quadrilateral ABCD is a rhombus, a rectangle, or a square. And we are saying that ABCD is a rectangle. Opposite angles of a parallelogram are congruent. So the measure of angle D, which is, if this is a parallelogram, remember the opposite angles are congruent. So if this is 90 degrees, this is 90 degrees. And since consecutive angles are supplementary, if this is 90, D and C have to add up to be 180, so this also has to be 90. So then we can say that parallelogram ABCD has 4 right angles. You cannot conclude it's a square because we are given no information about the side lengths. All right, so now let's look. E, F, G, H. We are looking at, is it a rhombus, a rectangle, or a square? And we have to explain it. Some of my students last week did not explain, so they got it wrong. I agree. It is a rhombus. It's already said that it's a parallelogram, so check that off the list. A parallelogram is going to have opposite sides congruent. So that means GF is congruent to EH. EF is congruent to HG, which means all 4 sides are congruent. And then we can't say it's a square because it doesn't look like they're right angles, but we're given no information about the angles, so we can't conclude that it's a square. All right. Theorem 613 and 614 say that if you have a rhombus, then your diagonals are not only bisectors, but they are perpendicular bisectors. And then if you have a rhombus, then diagonals bisect the opposite angles. So if I am putting this in my notes, I definitely want to highlight that it's a 90-degree angle there. And I want to highlight which angles are congruent. So the diagonals bisect the angles. Not only do they bisect the diagonals themselves, but where it hits the vertex, it cuts that vertex right in half and creates congruent angles. So when we're given a problem like this one here, what are the measures of the numbered angles in rhombus PQRS? So I know that angle P is supplementary to angle Q because it's a parallelogram. So I go, angle P is 180 minus 104, which is 76. Somebody please double check my math on that. And then because this is a rhombus, it bisects angle P. So I know angle 1 is half of angle P because it bisects it. So what is half of 76? 36? 38. 8, thank you. So angle 1 is 38 degrees. And that is also angle 2. So angle 3 and angle 4, what are those? If we look up here, angle 3 and 4. So we know angle 1, measure of angle 1, is equal to the measure of angle 2, is equal to the measure of angle 3, is equal to the measure of angle 4, and that's all equal to 38 degrees. All right, the last theorem is 615. If a parallelogram is a rectangle, then the diagonals are congruent. So not only are the diagonals perpendicular bisectors, but they are also congruent. So let me show you guys how that works. If Ln is 4x minus 17 and MO is 2x plus 13, what are the lengths of the diagonals? So we are going to solve for x by setting these two pieces of information equal to each other. Because the diagonals are congruent, we set them equal to each other. We solve for x. Is equal to 2x. So x in this scenario is 15, but it doesn't want 15 as an answer. It wants the length. So we're going to plug 15 back in for x. 4 times 15 is 60. 60 minus 17, 43. 2 times 15 is 30, plus 13 is 43. Why are those the same? Because diagonals are congruent. What type of triangle, let me erase this so we can answer the question. What type of triangle is PMN? If this is congruent to that, then PMN must be, your options are scalene, isosceles, equilateral. Isosceles have two congruent sides. So it's isosceles because the diagonals of a rectangle are congruent and bisect each other.